Hi, today what we're going to do is talk about how to solve equations, and in particular we're going to be talking about linear equations, and those are linear equations in one variable. So in order to solve equations, basically what you need to do is you need to go find x. That's what it means. Go find x. At the very end, what you want to end up with is you're going to do some algebraic manipulation, and you're going to end up with something that looks like x equals. So in the end, when you're told to solve an equation, you will have something that looks like x equals. Now we're going to discuss today two different types of equations. One of them is called a conditional, and that's just the typical equation that you're used to solving. You'll end up with something like x equals some number, and it might be 5, or x might equal 2, just something of this sort. An identity equation, you're going to end up with something that looks like, well, if you try to solve it, you'll end up with actually a true statement. You'll have something that might look like, say, 2x minus 4, and let's say you're given this and they tell you that it equals 2 times x minus 2. You would try to solve this thing and you would end up with 2x minus 4. When you distribute this to get rid of your parentheses, you would get 2x minus 4. Now if you look at this thing carefully, you'll see that it just says the same thing equals the same thing. So no matter what value you put in for x, you will get an equivalency. So in this particular equation, everything works. And this is what happens when everything works. You'll say x is an element of anything from negative infinity to infinity. Might be one way that you'll see this written, or you might see it written as x equals, or x is an element of, we'll just say x is an element of the real numbers, meaning x is any real number. All right, let's look at this particular equation. This is a typical linear equation. You would solve this by adding 7 to both sides, and you would get 3x equals 12. You divide both sides by 3, and you would get that x equals 4. This is a conditional equation, and it is typical of ones that you've solved in the past, I'm sure. All right, looking at another equation, this doesn't look like a typical linear equation, but we'll see what happens. I'm going to look at this one, and it's everyone's dreaded equation. It's fractions. But I can manipulate this thing just a little bit by saying that I want to multiply both sides by, and I look at the denominators and I see that a 10 would be a nice common denominator. So instead of manipulating it as fractions, I'm going to multiply everything through here by a 10. So I'm not changing the equation at all because I'm multiplying both sides. You notice that both sides are in parentheses, and I'm multiplying everything through by a 10. I'm going to distribute this here and here, and I will get 10x over 5 minus 10x over 2 equals 3 times 10 is going to be 30 plus 30x over 10. What's nice about this, as I did this on purpose, is that each of these fractions reduces to a whole number. And you can make this work in every case. You can reduce each one so that you get whole numbers, and then you have nice pretty numbers to work with. And it would look something like this, and that is much better. So I'm going to go ahead and combine this left-hand side. The 2x minus 5x is going to give me a negative 3x equals 30 plus 3x. I'm going to add 3x to both sides and subtract 30 at the same time so that I move the 30 over to this side and add the 3x to both sides so that I get 6x. In the end, I'll divide both sides by 6, and I'll get that x equals negative 5. And this is another conditional equation, just a typical one to solve. And it's nice when you can get rid of those denominators. And I'll show you another more complicated one in just a second. Alright, now here's a nice equation. You see he's really messy looking and he's got fractions in him, so he looks really hard. So let's try to get this one done. Once again, I'm going to go ahead and get rid of these denominators by multiplying both sides by what would be the common denominator. So multiply both sides by 2x plus 1 times 2x minus 1. Seeing as these two have nothing in common, I have to use the multiple of the two. So 2x plus 1, and I'll need a 2x minus 1. Alright, I'm going to multiply both sides, which means I'm going to distribute this whole wad of stuff to here and then to here. So in multiplying these two, notice that the 2x, and let me go ahead and show you that this is understood to be over 1. You'll notice that the 2x plus 1's cancel. That's handy, leaving me with just 7 times 2x minus 1. And then I'm going to get minus, and then I'll have an 8x, and it's going to be multiplied by, when I multiply this whole nonsense right here, this whole wad of stuff, times this one, the 2x minus 1's cancel, leave me with 8x times 2x plus 1. Now this one isn't very nice at all, but I do have a negative 4, and I'm going to go ahead and multiply this thing out because I'm going to end up needing to do that anyway. And some of you will say I'm just foiling it out. That's exactly what I'm doing. I'm going to say that's 4x squared, and then I'll have a minus 2x, a plus 2x. The middle term will drop, leaving me with just a minus 1. Alright, I'll need to distribute all of this, combine like terms, and see what that gets me. So I'll have 14x minus 7 minus, distributing my 8x, this will be 16x squared, minus, and be sure and distribute this negative. That's one of the most common mistakes I see. 8x times 1 is just 8x, and then that will equal negative 16x squared plus 4. Alright, now I'll need to combine like terms. I've got a 14x minus an 8x, so that'll give me 6x on this side, minus 7. I think I'll add 16x squared to both sides, which is going to end up dropping this entire term. So that's handy. Equals, and then it looks like I just have a plus 4 over here. Nice. This is, again, a linear equation in one variable. I say it's in one variable because there's just an x, no y. I'm going to add 7 to both sides. It's going to give me 6x equals 11, and then x equals 11 over 6. Nice answer, a conditional equation. One thing I do need to check, since I do have x's in the denominator in this case, right here, I have x's in this denominator. I do need to check to make sure that the answer that I got doesn't leave me with a 0 in the denominator, because a 0 in the denominator is undefined. So I check to see this one right here. If x were 1/2, then this guy would have a 0 in the denominator. My x is not 1/2, so I'm good there. Right here, x would need to be equal to negative 1/2 to have a 0 in the denominator, so that is okay as well. So I don't have any discrepancies, no undefined terms, so this one is good to go as well. Now, if you're having any trouble with these, be sure to post a question on the discussion board or attend an eLive session, and I can answer any questions that you might have on these.